We begin Unit 16, solving exponential equations with like bases. If an equation consists of two equal exponentials of the same base, set the exponents equal to each other and solve. In other words, if some general function b to m exponent is equal to b to the n, then we set m equal to n. Example 1. The first thing to do is look and see if the bases are the same. In this case, both the bases are 3. We don't need the bases if they're the same. Set the exponents equal to each other and solve for x. Divide both sides by 2 and x is equal to 5. Example 2. 2 to the 3x minus 3 power is equal to 2 to the x plus 1 power. Look at the bases. They are the same. So we just need to deal with the exponents. Set the exponents equal to each other and solve for the variable x. If I add 3 to both sides, we get 3x is equal to x plus 4. Subtract x from both sides to get 2x is equal to 4. Dividing by 2 leaves x is equal to 2. You can always check your answer by plugging in your answer back into the original exponents to see if they're equal to each other. And if I plug 2 back up here, 6 minus 3 is 3, and 2 plus 1 is 3. So this is my answer. Number 3. Look at the bases. Both these bases are the same. So we set the exponents equal to each other and solve for x. I need to get my letters to one side and my numbers to the other. Moving 3x to the right hand side and subtracting leaves 0 on the left side. 0 is equal to x, and this is my answer. Example 4. In this problem, we have to use the laws of exponents in order to simplify before we could solve for the variable x. In examples 1, 2, and 3, there was only one base on each side of the equal sign. In example 2, there was a 2 on each side. In example 1, there was a 3 on each side. But in example 4, I have 2 bases on the left side. So before we can solve this problem, we need to condense and simplify. So using the laws of exponents that we learned in Unit 15, when we multiply like bases, we add the exponents and the base stays the same. So when you multiply like bases, add the exponents. Now I have one base on each side of the equal sign, and they are alike. Now I can set x plus 2 equal to 8 and solve for the variable x. Subtracting 2 from both sides gives me x is equal to 6. I'm going to let LB be equal to like bases and E be equal to exponents. Next example. I have two bases again on the left side, and I need to simplify it to one base. So using the exponent rule or law that says when you divide like bases, subtract the exponents and the base stays the same. So I'm going to subtract and bring this one up. Leaves us 2 to the 5th. When we divide like bases, we subtract the exponents. So now I have 2 to the x minus 3 power equals, or 2 to the 5th power. Set these equal to each other and solve for x. Add 3 to both sides gives us x equals 8. Last example. In this problem, I still have two bases on the left side. PEMDAS says take care of the parentheses first, and I have a power raised to a power. The law of exponents says when we have a power raised to a power, we multiply the powers. So 5 to the 2x power times 5 is equal to 5 to the 7th power. I still have two bases. The other law of exponents says when you multiply like bases, you add the exponents and the base stays the same. Remember, there is an understood 1 here. So I have 5 to the 2x plus 1 power is equal to 5 to the 7th power. Now I have one base that's alike on each side of the equal sign. So I set the exponents equal to each other and solve. Subtracting 1 from both sides gives me 2x is equal to 6. Dividing by 2 leaves me with x is equal to 3. And we are done with the first flap of our foldable.